discuss. My topic is emerging innovation in concrete. So I will brief. We have 27 value-added products, and it has been categorized into 6 different categories. So based on their application and their usage. So here, like some products, Prism self. So we have a self-compacting concrete, which concrete doesn't require any compaction. This concrete is filled the formwork without any filling defects, and here this is very useful for construction industries. We have some of the products like Prism Cure. In this concrete, no need to do the curing of concrete. So the curing compound is this integrated curing material is added into the concrete, and this concrete is useful for this wherever the curing is difficult at particular location. This concrete is very useful. We have this Prism Mini. So generally we supply the concrete in transit mixer in terms of 6 cubic meter, 8 cubic meter based on the transit mixer capacity. But sometimes the requirement comes for a very small quantity, 0.5, 1 cubic meter or 2 cubic meter for a smaller construction. For that application, we have developed the concrete which can supply in bags of 30 kg bags and minimum 40 numbers. And the concrete, this workability is retained up to 6 hours. And this concrete do not require any further treatment. It is ready to use. Just need to open and need to pour into the structure. So we have a different grade of concrete from M20 to M80 as per the requirement. And here further we'll discuss some of these products. So here we will discuss this on Prism Green. So Prism Green is not a green concrete, but it is eco-friendly, low-carbon concrete. So in this concrete is a high-performance concrete, and it is designed to meet the environmental objectives. And this concrete is durable, and it is a low environmental impact. So in this concrete, actually, we have replaced this ordinary Portland cement with other pozzolanic metal like fly ash or GGBS with higher amount of pozzolanic metal with using some of the special admixtures, and sometimes we use some of the ultrafine materials to get this desired performance. And in some cases, we replace the natural fine aggregate with this manufacturer aggregates. Right, there are many aggregate suppliers. They have started producing the aggregate, construction and demolition waste aggregates. That can be used. We can use the concrete for partially replacement of the fine aggregate. And some places we have these copper slag aggregates and iron slag aggregates. So these are the raw materials which generally use to replace these natural aggregates. And here we have given some comparison. We have done many trials and we have done comparison. And if you compare with the embodied CO2 kg per meter of concrete in M30 grade, if it is used 100% OPC, the embodied CO2 comes around 289. If you go with higher amount of fly ash, 35% or triple blend, or in case of 60% GGBS, it is just 136 kg per meter cube of concrete. So you can just see here more than 50% CO2 we can reduce by using this concrete. And this concrete is without compromising quality, and also the durability parameters are very good compared to standard concrete. So here some of the advantages of this green concrete. So better workability, because here actually we use some of this pozzolanic metal like fly ash. Fly ash is a spherical particles, and these spherical particles to work as a ball bearing effect, and which reduce the water demand in the concrete. So it's improve the workability, long term strength gain. since this pozzolanic metal is continue this strain gain for a longer period, and it's make the microstructure in concrete is minimize the voids in the concrete, and is continue the strain gain beyond 20 days of this age. Lower heat of hydration. In case of mass concrete, it is very useful because it reduces the heat of hydration. We replace the cement, and hence that much of quantity of heat is reduced directly, and we can control the thermal cracking in case of mass concrete. Sustainability is CO2 reduction, because this we are reducing the cement content. The CO2 of this manufacture of cement is very high. It is globally around 8% of this, total global CO2 emission while producing the clinker. So we reduce the cement content of more than this 35 or 50%, then we can directly reduce this CO2 reduction. And waste utilization, since these fly ash, jejibas, or these are the industrial waste which we use the concrete, which is actually very challenging for the disposal of the metal. So that's why we are using in this concrete, and it is very useful. And durability enhancement, so reduce the permeability and leaching of lime. Since this when we add the pozzolanic metal, generally the pozzolanic metal they consume this calcium hydroxide in concrete, and hence it's no make additional CSS gel, and it feels the it is give the concrete higher strength, and also it fix the voids inside the concrete, and it makes the concrete no this reduce the permeability, and also it helps to leaching of the limes, and it is very helpful for the resistance of the chemical attacks. And this is cost, this is if you compare the cost, because this pozzolanic material is cheaper than this cement, so it is a cost effective solution. So the application for this particular green concrete is for the raft foundations, for PCC, and for the concrete pavements. This, where we can use this product. So second products, we have this lightweight concrete. So lightweight concrete means the concrete density is less than 1800 kg per meter cube. Generally, the normal concrete densities comes around 2400 to 2500 kg per meter cube. The density of concrete is not fixed. It is depend upon the specific amount of raw material used in the concrete. Here, actually, we replace this natural aggregates with this lightweight materials, and we make the concrete lighter. Suppose here, if you see the concrete density less than 1000, it is flowing over the water, because the water density is 1000 kg per meter cube, and concrete is floating over the water. So here, some of this performance of this lightweight concrete, the density is this product we have is 600 to 800 kg per meter cube. Concrete strength is 1 to 5 MPa only. So that's why this concrete we prefer only for the non-structural applications. And the workable duration is more than 220 this and setting time is less than 10 hours, and our volume, targeted volume, is 1000 liters 1 cubic meter we design generally. And here density we discuss. So application is very important. This lightweight concrete is used for replacement of the brick bed coba. Generally brick bed coba is used on the terrace of the terrace slab to cover the waterproofing layer. So in that brick bed cover replacement, this is best solution. And also for the filling purpose, for insulation purpose, or the filling the sunken portion, this concrete is very useful. And the compressive strength is 1 to 5 MPa. That's why we suggest only for the non-structural applications. And this protection layer is required, which is the strength is 1 to 5. So the either screed or tiles is need to be put over this concrete. So the reduction of dead load, if you compare with normal concrete of 2500 kg per meter cube density with 150 mm thickness, the dead loads comes around 375 kg per square meter. We compare with the same lightweight concrete with 1000 density with the same thickness, the dead weight comes is just 120 kg per square meter. So it's around 60% of dead load is reduced by using this concrete. And further it is absorb the sound, so it is the sound insulations, and thermal insulation. So if you see, since we are replacing with brick bed coba, the value of brick bed coba is just 0.75 watt per meter Kelvin. But if you compare with this density of 1000 and 1600, it just 0.281. So it is just half of this this no value of the brick bed. So the this thermal conductivity is better than the brick bed cova. So here, next products we have this Prism Pervia. So Prism Pervia actually is eco-friendly pervious concrete. This pervious concrete here we do not use any fine aggregate. We manufacture this concrete only by using the coarse aggregates. So one type of coarse aggregate only 12.5 mm with BSM aggregates we use in this particular applications. And this concrete generally permits the water to percolate from the ground to the underground soil. So the rainwater or stormwater can be this penetrate underground soils. So this concrete generally the strength we can achieve up to 15 to 20 MPa, and the wides we design for 15 to 25%, and the workability of concrete is zero slump since there is no fines in this concrete. And the permeability, if you see the permeability, water permeability is 300 liter per square meter per minute. So in 1 square meter area per minute, the water permeability is very high, 300 liters, since the wise ratio is very high. And there is three different systems generally used when we know this is this concrete, pervious concrete, system A, B, C. So in system A, generally is permeable layer over that the aggregate layer is placed, and over that the pervious concrete is placed. So the water can be penetrate through aggregates to the soil, permeable soil. In second application, the drain pipe is placed in these aggregates, and this there is semi-permeable soil. So when the concrete is placed, so the pervious concrete, then it is penetrate through aggregate and through the underground soil. And third application, there is an impermeable soil, and here actually impermeable membrane is placed over this soil, and the drain pipe is placed in this concrete. So when we know when the water is comes, rainwaters or any type of water, then it is the water is drained out and it is stored in different places or in tanks or any other places. So this is the three type of systems used for this pervious concrete. And this advantages are this storm water management and its skid resistance, since the surface is rough. So this is better for skid resistance. Noise reduction, it is eco-friendly, low maintenance, and it save the water, and it is having the high porosity. So the application area is car parking, driveways for light vehicles, and for courtyards, for pedestrian, for playgrounds. These are the application where we can place the concrete. So our next products is antibacterial concrete. This particular material actually, when we add into the concrete, is embedded antibacterial agent integrated into concrete, and is uniformly dispersion ensure total surface of the coverage, and it's uniformly shielding over the entire concrete structure. So these are the main advantages. It's hygienic advantages, efficiency, sustainability, uh, aesthetic maintenance, and durability. So since there is reduced the chemical usage is not required to clean the surface, since we have already added this no this antimicrobial agent to the concrete. So these are some of the application. So where we can use healthcare facility, commercial spaces, research lab, public spaces, and food processing units. There, this concrete is very useful. So this is all about. So thank you very much.